Hello, we are back with another episode of Maker Show. Today's topic is about building a remote controlled robot arm. That sounds very exciting. My name is Sherry List, and I am your host today, together with a good friend of mine, Goran Wukshik. Hi, Goran. How are you doing today?
Hello, Sherry. I'm doing great, and welcome everybody to the Maker Show. It is a monthly show. We are running for 1 hour. On each episode, we highlight cool projects from the community, and we hope those projects can inspire new creations and inventions. So, we usually highlight projects focused on IoT and AI, and I also hope that some of you who are watching will join as speakers, and that will be your opportunity to get Azure Hero Maker badge. But if you stay tuned until end of the show, you could also learn. You could also get a learner badge. So, Sherry, who is our speaker today, and which cool projects we have?
So, before I jump into the speaker, I know everybody is waiting for that part, but I want to mention you that no matter that from where you're watching us, is it Learn TV, YouTube, Twitch, or Facebook, you all have opportunity to type your question for the speaker in the chat. You can also tell us that from where you are watching us, or interact with each other. We really want to see some interaction in our chat. Let's say it like that. But we also want you all to familiarize yourself with our code of conduct, which I highlighted here. But in short, we just really want you all to be mindful and respectful of each other. And we are also going to enforce our code of conduct. Hope we never need to do that, but if it happens, we really enforce that. And as for our speaker today is Pete Gallagher. He's joining us today, and he is a freelance IT consultant, Microsoft certified trainer, Pluralsight author, and Azure MVP. So it's a lot. So he's doing actually a lot of things in the community, but also he is owner of PGG Creations. So welcome on the stage, Pete. Hi,
Hey,
Pete.
how's it going?
Hello.
Yes. So, I mean, before everything, I want to say happy St. Patrick Day and thank you very much
Yeah.
that you're
Happy
joining
St.
us
Patrick's.
on this day.
Yeah, I mean, I suppose it's a good job it's not 5 o'clock in the UK. Otherwise, maybe I'd have to have a Guinness to celebrate. I think it would be forgiven. Most of my family's from Ireland, so I do tend to celebrate it. But
Yeah.
yeah, it's the middle of the week. You can't celebrate too hard.
Yeah, true, true. So before you take over the stage, will you share some interesting fact about you to our audience?
Yeah, I mean, you kind of alluded to that. I mean, people that I know tend to laugh at how busy I am, and I am. I'm just silly busy. I tend to. Do you remember? I don't know if you're old enough to remember. There was a Jim Carrey film called Yes Man where something happened to him and he couldn't say no, and I kind of feel like that happened to me the last few years, and I've just said yes to a lot of things. But I've had an awesome time, and I've learned so much in that time. But yeah, I mean, away from doing IoT, then I'm a geek everywhere. I like Star Trek and things like that, Formula One, but I do like sports like rugby as well. So yeah, I do sometimes not sit in front of the computer doing IoT.
Okay. The reason that I was going away was that I really wanted to find a book for you that
Ooh.
a friend gave it to me, and he said that learn to say no.
Oh
The
yeah.
Yes. Yeah, I couldn't find it here. I guess it's in the library. But the issue for me is that I could never actually even start reading that book. So I only have, maybe I should post it to you. And if you ever had time to read it, maybe then you'll give me a resume of that.
Yeah, see, this is a trick question. I've got a friend, Jonathan Relf, who said this to me. He said, "You need to start saying no." And to that, I said yes. And he went, "Well, you've not started very well, have you?" So, And it's true. When am I going to get time to read a book on saying no? You know, I'm too busy saying yes to other stuff.
That's the issue. But you also run a lot of different shows as well. Maybe you can share with our audience the shows that you have.
Yeah, I mean, I co-organised .NET Knots with Jess White, who's a fellow MVP. She's awesome. So that's one of the biggest meetup groups that I organise. I organise Knots IoT as well, so not too dissimilar to the show that you've got here. We have a speaker on regularly to show us some cool IoT stuff. In fact, we've got Olivier Block tomorrow night at 6:30
that's
GMT.
exciting.
Yeah, Olivier's awesome. I like Olivier. So there's that. We're in real times when we're allowed to meet in person. Then I co-organise Knots Dev Workshop as well, which is more hands-on, follow along with the speaker type experience. But we've not really wanted to do that until we're back in person because it's difficult running workshops virtually, although it's doable. I'm also a member of a podcast, Agile Engineering Podcast, where we talk about DevOps and Agile type stuff. And I run a Twitch channel with Jonathan Rell from Liam Gulliver called Azure-ish Live. And on that, I've got a show called IoT Live, where Clifford Aegis and myself talk about all things IoT. And then on a Thursday, often we will do an end-to-end IoT development type follow-along show. We had Benjamin Carbe from the Microsoft IoT team on to do a LoRaWAN workshop with us for the last few weeks. So there's that as well as everything else to do, but they're kind of the highlights.
That's exciting.
Nice.
Maybe you should share all of these links to us. We are going to send a follow-up email. We can highlight it. And actually, Goran is also going to publish like a resume of our show. We can include it there for
Yeah.
people
So
to-
after the show, we'll have the short blog post where people who missed the show can still watch the video and can read about it, and some relevant
Perfect.
links are
Yep.
always good. Yeah.
That'd be about 7 pages of A4. Is that all right?
And I need your address to send you that book. So
Oh yes, absolutely. No, sorry, no. Yeah.
you're learning it. That's great.
My internet said no about 5 minutes before this show started. We came on about half an hour before the show, and then 5 minutes before we were supposed to go live, that's when BT decided that they'd just interrupt my internet connection. So there was lots of panic and shouting, and thankfully it all came back, and we'll see. I'm a little bit stressed as a result of that. But still coming.
Sherry would assemble some robot arms and do live demo, right, Sherry? As a
Yeah.
Great. Okay, so shall we get started?
Yeah, absolutely. Yeah. Do it.
So
I've
going to
started
share
sharing my
it.
screen already, so you should
Yeah.
be able to see that.
Yes.
So normally this talk I would just do sitting behind slides, but I've asked Sherry and Goran to stay with me, and I want this to be a little bit more conversational. So there will be slides, and I'll flash through them. But feel free to ask questions, and I've given Sherry and Goran free license to just interrupt me and ask me questions as we go. So don't hold back and feel free to go. There are a lot of moving parts in what I'm about to do as well. So likely that something will go wrong. And in fact, it did even when I was trying to get this set up earlier. So it's what happens when we're doing live demos. But yeah, we're going to talk about building a Raspberry Pi robot arm driven with .NET, Blazor and SignalR and some other things later on as well. We've already briefly spoken about me earlier, so I'm not going to go through all of the many words on there, but generally you'll find me in and around IoT and talking about that and trying to help people with their IoT journey. So we'll get started with a brief introduction to .NET 5 and then how we go about installing that on a Raspberry Pi. And then we'll do Hello World with that as well. And then we'll talk about the Raspberry Pi GPIO and the circuit that we've got built up here, and then how basic GPIO works. And then we'll talk about driving the servos and what we need for that, including device bindings. And then we'll look at Blazor and SignalR, and then some final demos on there as well. And then Q&A, which will also happen as we're going. Obviously, shout if I go too fast, or if you can't see what I'm doing, or if my internet goes, you have to shout very loud. So .NET 5, in case you've not used .NET 5, it's now cross-platform. It allows us to be able to target pretty much anything we like, including IoT there, second from the right, which is useful. It's open source as well. Runs on the Pi. It gives us some nice features like records and init-only properties that sort of trap the code down to a couple of lines. Pattern matching on types, which I think is quite a cool thing to add. Top-level programs where Hello World was already quite small, and now we can do that in 2 lines. System.text.json has gone, which makes poor old James Newton King a little bit sad, of course. But Microsoft gave him a job, so he's still happy. I'm not going to go through too many of these stats, but the one that fascinates me is that bottom right-hand corner one where 40% of all new .NET developers are students. So I like the fact that .NET is propagating its way into universities and colleges where Python and C would normally be the mainstay. So I think that's quite important. And the stuff that I do with IoT is another way to drive it in as well. So being able to do IoT and C# together is great. I like that. So getting .NET on the Pi is normally quite a difficult process because there's an AMD 64 or a 64-bit install, but there's no 32-bit version of that. So you've got a whole heap of instructions you'd normally have to go through. But I've made a single line install script for that. And again, Sherry and Goran are going to share the links to these slides at the end. And I'll put all of the links in there, so you don't need to worry too much about noting this down. But you literally just run that single command and it will install everything you need to get .NET 5 up and running. And all you need to do at the end is reboot your Pi, and you'll have a version of .NET installed on there. So that just makes life far easier. And it was nice to see people when they're tweeting to say how easy that is for them, and it's nice to see that. When you've got that installed, then if we switch across, I've got PuTTY open here, so we've terminaled into our machine. Now, normally I'd do a Hello World demo here, but that's a little bit boring. But what I will show you at this point is that we've got .NET installed correctly. So if I zoom in a little bit, you can see that we've got the version 5.0.102 of the SDK, and it tells you a little bit about the version of operating system we got in there. When I said AMD, I meant ARM earlier, obviously. So that just tells you that that's all up and running, which is a good place to get to. But before we carry on, we need to talk a little bit about GPIO, which is General Purpose Input Output. And this is all of the pins that you'll see along the side of your Pi that allow you to control things like I/O and SPI. And to control those with .NET 5, you can use the system.device.gpio library, and it's just a NuGet package, and you just install it from the CLI, and then you've got access to the GPIO on the Pi. It supports the Raspberry Pi and BeagleBoard and Hummingbird and Odroid, but I'm a Raspberry Pi guy, so I tend to just stick to that. It supports Linux and Windows 10 IoT, and I don't recommend anybody use Windows 10 IoT. I think the last update to that was October 2018 or something, so it's kind of falling out of fashion now, especially as .NET's cross-platform, and there's things like the Uno platform, which we'll get to later. So GPIO I mentioned earlier, so we've got 40 pins on the side of the Pi. And if we zoom in a little bit, we'll see that they've got different functions. There's power, and there's UARTs for serial transmission and reception, and PWM you'll see in the bottom sort of right-hand quadrant of that circle there. There's actually 2 different numbering schemes you'll be able to see there as well. So there's the numbers closest to the pins, and they start with pin 1 at that top left square pin and go across 2, 3, 4, 5, 6. And this is my preferred numbering scheme because I can count pins. Once you know how the pins are ordered, then you're off. There's also this BCM numbering scheme that is related to the BCM chip that's driving the GPIO. So you can use that if you like, but then you're into converting BCM into GPIO pin numbers and then going from there, and well, it just seems senseless to me. So just stick to board numbering. Life will be easy. I've got a circuit set up down here, which I'll show you images of later, but the basic idea is that I've got an LED connected through a resistor here on pin 10, and I've got a button connected down to ground through the button on pin 26. So this is Hello World for IoT solutions, really. You get a flash and LED and read a button, and once you've done that, then you jump up and down and start clapping because it's working. So let's have a look at those demos working on here. So I've got some code already provisioned here. So if I get it on the screen, and I'll zoom in a little bit so you can see what's going on. So, and I get rid of this. I don't need to see the side of that. So we've got our system.device.gpio NuGet package, and we're referencing that at the top here to give us control over the GPIO. And then I leave this hello world line in there because if you're just reading a button, for instance, you're not going to know whether the program's actually started or if something's gone wrong or whatever, or if it's ready for you to press a button. So I leave that line in there so I know that it's ready. Then next up, we've got this GPIO controller line here, and this is what's going to be doing the heavy lifting of most of what we're going to be demoing. And you'll see that I'm passing in that board numbering scheme rather than the BCM numbering scheme there. So that's why I thought it was important to mention that. We make a couple of variables here. So we've got pin 10 reference there. So if you remember, I've got the LED connected to pin 10. So that's that reference there. And then I'm creating this light time variable that I'm using because we're going to turn an LED on and then wait for a bit and then turn it off and then wait for a bit and then turn it back on again in a loop. And so that light time is going to give us the delay between those. Otherwise, it's just going to look like it's sort of half on, which is no good. So wrapped in a try catch down here, which is what you should be doing. We've got a controller.write. So this is that GPIO controller. And we're going to write to that pin that we'd specified as 10 earlier, a value of high, which will turn our LED on. And then we've got that wait that I mentioned earlier. And then we write a value of low to turn it back off again. And then we wait, and then we go back round that loop, and it just sits there doing that. And then when the program exits, we close the pin just because it's nice to tidy things up like that. So if I switch this over to here, and we start running that. And now I've also got a webcam view down to my Raspberry Pi, and what we should see is the LED start flashing if everything is working correctly, and then we have an LED flashing. You should be able to just about see that, but let me zoom in so you can see that properly. It's flashing down there. So that is, once you've got to that point, actually it's pretty cool. Now you've got some level of control over the GPIO, and you should be clapping yourself at that stage, and life is good. But that's just input control. We haven't got any output control. Rather, that's output control. We haven't got any input control. We're not reading the button yet. So if I switch across to the code again, then I can switch branches. I'm not going to do any live coding because I'm nowhere near that brave. So I can switch to the read button branch, and I'll just briefly describe what we're doing there. Most of this code is going to be exactly the same, but we are going to get an extra pin when it's done it. Sometimes this could take a second. You can do it. I need to close the program and open it back up again. There we are. So what we've got here is all the rest of the stuff. We're still spinning up the GPIO controller, still spinning up the pin for the LED, but now we've got an extra button pin variable. And again, we've got that connected to pin 26. Now, I'm opening that pin just like I was with the LED, but I'm specifying input pull-up. Now, this is important because on that circuit, look, we've just got one side connected to the button and the other side connected to ground. The way inputs work on devices like this is there's something called open collector, and they can just float around as you will. And if you connect one side to ground, that's great. When you press a button, you're going to get ground, but if you don't press it, it's just going to float around. But what you can do is you can specify this input pull-up, and what that does is internally in the Raspberry Pi, it pulls this up to a high level, and it makes sure that when it starts, it's definitely high, and when you press a button, it goes definitely low. But on the flip side of this, it's going to make the code look a bit backwards because we're going to read that button in here, and if it's false, then we're going to turn the LED on. So that's going to sound a little bit backwards, but when we press the button, it's going to go low, which is going to read a false, and that's when we want to turn the LED on. And if we don't press the button, then we turn the LED off. So it can make your brain melt a little bit if you don't do it that way around. I mean, obviously we could flip the circuit around if we wanted to, but it just makes the circuit nice for me. I like it that way around. And then we close a pin. I probably should close the button pin as well, but I was lazy, so I didn't. So if I run that now, and then I switch back over to here and zoom in a little bit. So you can just about see the button where those wires are. And if we just wait, you see the LED's gone out, and it might not be very easy to see, but you should be able to see just about enough of that. If I press my button now, then you see the LED comes on. If I point it up a little bit, then you might be able to see that a little bit better. You see that? So the LED is, yeah, exactly, it works. So the LED is now flashing. I mean, that's the most complicated way of connecting an LED to a button that you'll ever know. I've got a Raspberry Pi in the middle of it and a bunch of wires and code. But now you've proven that you can read inputs and write outputs, and you're on your way at that point, which is cool. I like that. So we're happy. So moving on a little bit. The next part I want to talk about is something called the IoT device.bindings NuGet package. Now, this is a whole heap of code that somebody else has written, a few people, in fact, that allows you to be able to interface directly to peripherals. And one of those peripherals is a servo. Now, a servo is a little motor that moves between certain angles, and that's going to be the basis of our robot arm. But it allows you to control other things like temperature sensors, temperature humidity sensors, I/O expanders, so input-output expanders. If you want more inputs and outputs, then you can get little chips that you can plug in to do that. Explorer hat, the Sense hat. I've not got one hanging around here, but Tim Peake took up a Raspberry Pi with a Sense hat on top of it, and it's got a few LEDs for a display and a magnetometer and a gyrometer and temperature humidity sensor, and children are able to write experiments and run on the space station. It's really cool. So it's a really great way to
agree
go.
on that.
Yeah, I love that. Astro Pi, it's called Astro Pi Zero, has just finished, I think. It's a fantastic initiative to get children into STEM subjects. So go and check that out. And yeah, it runs servos as well, which is great. So I've got a circuit here that I've made up. So I've got this little thing called a Monk Makes board. Now, you can plug a servo directly into the Raspberry Pi, but you run the risk of burning out the GPIO pins because it can take 300 milliamps, and a Raspberry Pi is only rated at about 30 milliamps to drive anything. So this servo board here, all it does is it separates out the power and the control. So you can see sort of top left there, we've got, I don't know if I can zoom in, we've got this battery connector here. So I've got some batteries plugged in, just 4 AA batteries, and that just handles the power to the servos then, and it's happy. And then we've got a bunch of pins connected up to the Raspberry Pi. So sort of zooming in on that, we've got ground on pin 25. If you ever do buy this board, and again, I've got a GitHub repo with the full workshop instructions for this, and it's got the shopping list to that board in there as well. If you look at those numbers, it can be a bit confusing, but that first pin's ground. It does say it, but you can miss it like I did when I first plugged it in. Then I've got the first PWM on pin 35, and then the second PWM on pin 13, and the third PWM on pin 12. So I've got 3 PWM pulse width modulation ports set up on the Pi. And then on the other side of that board, I've got the servos connected. And each of those servos has got a control wire, which is often yellow or orange. And then you've got red or brown and black connected down there for the power. So it's quite easy when you plug it in. You can't really get it wrong. You just make sure that you've got that tiny little C lined up to the orange or yellow wire, and you're off. So that works. That servos, by the way, work with something called PWM. So you send pulses out of a pin, and you send short pulses, it goes one way. You send like medium pulses, and it'll go to the middle, and you send long pulses, and it'll go the other way. So that's kind of the basis of how this is working. You've got 180 degrees to work with these particular servos. A 360-degree robot arm would be a little bit, the wires would get all tangled up. So let's make the servos work, shall we? And do that. So I need to switch back to my code and switch to the, let's make sure that also I stop the code, because that can confuse things if I don't do that. I'm going to switch to a little demo that just exercises the servos. I'll let that go across, and I'll probably need to close the program and load it again. Sometimes it plays nice and sometimes it doesn't. So I've still got GPIO, but I've added threading in here, and I've added PWM and drivers and a servo motor. PWM and this drivers, that comes from that system.devices, system.device. library, essentially. That's where that's coming from. And then the IoT.device.servomotor is coming from the bindings NuGet package. So 2 separate places. So PWM, that's kind of native in that GPIO control NuGet package. And then this is the whole heap of somebody else's code that controls peripherals that I'm making use of for a servo motor, because I don't want to have to worry about PWM frequencies and duty cycles and stuff. It handles that for you. A little bit further down again, still got Hello World, but I'm creating a PWM channel here, and that takes 3 bits of information: the chip number, the channel number, and then frequency. We just leave the frequency as it is because it works. There's only one PWM, hardware PWM channel on the Pi. The hardware PWM is handled internally by the Pi itself. You just tell it what to do and it does it. And then there's 2 different channels on that PWM, 2 different pins that we can be using. Once we've created those 2 PWM channels, we can pass them into a servo motor. So we pass in the PWM channel, and then we specify the maximum angle, 180 degrees for our servo, and then the minimum frequency and the maximum frequency. And that's what those 2 numbers are doing. Depending on which servo you buy, and I bought like 10 for £1 from Amazon, you might need to change these 3 numbers just to make it work exactly right. And it's trial and error. So have a play. Now, as I mentioned, there was only 2 hardware PWM channels on the Pi, so we can actually create what's called a software PWM channel, where we send those frequencies in software. But that's hard for the Pi to do, because doing anything real time on the Pi, because it's got an underlying operating system, is difficult. But thankfully, the people that have written this have made it cinch to do. We pass in this true at the end, and that puts it into a high fidelity clock mode, high accuracy clock mode. So that gets over that worry. I'm not sure how they've done it. I've not looked at the code, but it's quite cool. Excuse me. We pass in a pin number, and we also pass in the frequency again. I forget what that 0.5 is now. I think that's the duty cycle. And then we use it just as we would on a normal PWM channel. We pass it in and we give it a couple of values. I've changed them because it seemed to need it. Then we start the servo motors up. And then I've got some code here that literally just makes my robot arm dance, and it just moves the bits between 2 different angles, and then I stop them. And I've written myself a tiny little routine. It just takes a servo and an angle and moves that servo. So let's see how that works. So if I run this and then switch back across to here and plug my power in. I leave it unplugged because it's on batteries and I keep forgetting to unplug it, and it's going to run out of power one day. There we are. So it's got 3 different servos. So it's got one that's doing the rotate at the bottom, one that's doing what's called the reach that goes up and down, and then grab at the top. So that's my robot arm dancing around in .NET. And that's I mean, I think that's cool all on its own, personally. And
Yeah,
I could just
it's
stop
great.
there and quit while I was ahead.
Yeah,
But but I'm not going to do that. I'm not going to quit while I'm ahead, because I'm going to chance it and keep carrying on with the demos. So, I mean, yeah, that's pretty cool. So let's stop that now, because it's going to get noisy in the background. And we'll switch back to my slides, and we'll talk a little bit about Blazor. So if you've not used Blazor before, that is a single-page SPA framework for creating client-side applications in .NET, which is mega. It started out as a pet project of this guy, Steve Sanderson, fellow Brit, I believe, who knocked this thing up in his own time, and he demoed it at a Microsoft conference, and a bunch of peeps from the, I think it was the ASP.NET team, spotted it and jumped on him and said, we need to do something with that. But the cool thing is that it lets you program the client side, the web UI stuff, in C#, where ordinarily you'd be in JavaScript. So it gets rid of the JavaScript almost entirely. You can still fall back to that with interop. But onwards from that, it's basic Razor and HTML like you would with normal ASP. There's a few different varieties. Actually, there's a whole heap of different varieties, but the 2 main ones are server-side Blazor, where you have an app that actually runs on the server, and you have a really tiny little thin client that runs in your browser. And over SignalR, as it happens, it sends DOM, document object model, updates down to your browser just to tell it what to update on that page. So that's great. It's really thin, and it doesn't tax the browser very much. But if it goes offline, then it stops working because it breaks that SignalR connection. So relatively recently in .NET Core and .NET 5, we got Blazor WebAssembly, WASM, and that runs in like a VM actually in your browser, and that pulls down actual .NET DLLs. So it's actually running .NET stuff in the browser, which is ideal. It's really cool, and it runs really fast. It kind of Blazor kind of says that, doesn't it? And then there's actually a combination of those two, which is what I'm using for these demos, where you have a server side and a WebAssembly side. And say you've got an API, or in my case, a SignalR hub that you need to host somewhere. You're not going to be able to do that directly in the browser, so you run that in the server side. And then your client that runs on the browser, that connects to it, and anything else can connect to that server as well. So yeah, all of this is plugin free and supported by nearly all modern browsers as well. So that's cool. And I mentioned SignalR, and that is a library for near real-time communications for .NET applications. It's mega. Open source, created by these two friendly people, David Fowler and Damien Edwards, way back in 2011. So this is mature now. It's been there for quite a long time. And it's a bidirectional real-time communication platform. And it supports WebSockets. And if it can't get WebSockets for corporate firewall reasons, perhaps it will drop down to server-sent events and long polling. It'll just figure its own way out. It's pretty cool. So we need to be able to drive the ARM. So we've got a few different bits that I'm going to do here. So if I switch back to my code, I am going to introduce you to the SignalR. Now, how are we doing on time? How long we got?
We are fine. We
Yep,
have
no worries.
some 20 minutes more.
Oh, awesome. That's fine then.
Yeah.
So I'm going to bring in the SignalR code. And again, I'll probably have to close this and open it back up again. And close that down. So nearly all of this is the same, but I've brought in SignalR and tasks because I'm going to be doing this async and HTTP because I'm going to need that too. I've converted my main into an async main now as well. At the top here, I've got a hub connection, and this is what I'm going to be using to connect my robot to the SignalR hub. So that's how that's going to work. I've still got Hello World, and I've still got my PWM setup that I've got there, and I'm still starting my servos. But down here, I'm creating the connection to my SignalR hub. Now, what I do need to do is replace this IP address, because this is all in a GitHub repo. So if I replace this IP address with the IP address of my PC, and save that, and remember to do that, then a little bit further down, I'm doing something which the code actually quite rightly says is dangerous. I couldn't get it to trust my certificate on the PC. I'm going to have the robot connect to the SignalR app that's going to be running on my PC, and I couldn't get the two to talk to each other without doing this. I saw that you could reset certificates on .NET 5, and I tried that, and that didn't work, so something else was happening, and really it didn't bother me because I'm doing this locally, so I wasn't really that bothered. And then I've got this automatic reconnect in case it breaks, and then we build that connection. And then down here, we hook up an event, and we're going to hook up this receive message event, and it's going to take in a user and a message. If you've ever done any SignalR, or when you ever do any SignalR, probably the first demo you'll ever make will be a chat app, because it's a perfect demo of real-time comms. So you have a user who sends a message, and that's kind of how that works. And I just usurped that demo. So my user is the servo I want to control, and the message is the angle that I want to send it to. So if my SignalR receives this servo 1, then I move servo 1, and likewise servo 2 and servo 3. And then we've got just a bit of console logging just so that I can see what's happening. And then we start that connection. Now, if I just did that, I think the whole thing would just stop because there's nothing stopping it. So I've got a while loop down here that just sits and runs then at that point. And then when the program finishes, I stop the servos. And then there's that same little routine. So that's great. That's perfect. But I don't have the other end provisioned yet. Now, normally what I'd do is I'd take you through the steps of provisioning Blazor and spinning up a new Blazor app and showing you how to build all the controls. But what I'll do is I'll just skip to the built one and I'll show you how it works. So I'm going to show you what it is that we're working towards. So we're going to have a basic Blazor app, and we're going to have some sliders for the 3 different servos. And when I move the sliders, it's going to move my robot arm in real time. So I'll show you the code for that. Drag this down. The main code that we've got is going to be sitting in this index.razor file. So as I mentioned earlier, we've got in the web project, we've got a client and a server. So we've got the client stuff that gets sent down to the browser that's going to be running on the client, and the server stuff that sits on the server and runs, and it's going to be mainly for our SignalR hub. There's actually a shared folder here as well that I'm not making use of, but if you've got models that you want to share between the client and the server, then you can create them in there and then share them, so it saves you replicating code. I'm not using that, but the default vanilla Blazor app will give you the weather forecast bit on there as well, which I've just left. It's fine. So on the client side, in Pages, you've got so I've got 3, because again, when you spin up the vanilla app, you've got that. And I've just modified the code in the index.razor page. And I've brought in this ASP.NET Core SignalR client in there and some other bits. And I've created 3 sliders. I've used this matte slider, this matte Blazor framework. It's a free open source framework, and I've got a link to that in the slides. It's fantastic and gives you stuff like these sliders that aren't standard in Blazor. When I move these, they're bound to a property down here. So if I scroll down a bit, I'll show you where they are. So you've got some properties here, Servo 1. And when that changes, I update a backing variable just so I can. And then I send a message to my hub connection, which I've set up here. And this is very similar to what I've shown you in the code on the Raspberry Pi, because it is the same. You know, the client is still just connecting to the same SignalR hub. So all this is doing is getting my actual URL and heading to this chat hub that I'll show you in a minute. And when I receive a message, I'm going to stick it on the screen. So that's what that bit's going to do. But down here, I send a message of Servo 1, and I send the Servo 1 value as a string across to the hub. And the hub is on the server. So if I expand the server and go to hubs here, then we have, and there's a few other bits of setup that you need to do, but I'm not going to go into too much detail with that. But you have this hubs directory, and in there you have a file with a class that I've called chat hub, and it inherits from hubs here, which is the SignalR hub. And in there, I've got a send message function that I'm calling. And all that's doing is sending this receive message with the user and the message out to all the clients that are connected, which, as you'll see later, is a pretty cool thing to do. So I've actually got this running already, as you saw. So if I pull that to one side and I get my code running over here as well, which is fine. And I also then get this on the screen at the same time. This is where all of the moving blocks are starting to fall together and it starts getting complicated. So that's going to take a little bit longer to run, and I'm waiting for Hello World to appear on there. So it should be listening. And theoretically, if I move this, then my robot arm is now moving, which is cool. Let's pull it up a bit. There we go. It's a bit rickety, you know, because the bottom part's got a servo in it, and when I was putting it together, I forgot to screw it in. But to screw it in now, I've got to take the whole robot arm to bits. So actually, I like it being rickety. It's fine. It adds a little bit of character to my robot arm. You can see here, this Servo 3 is the software PWM servo. Now, if you don't set that high precision timer option on that, then you get it kind of looking like this, where it moves like in big steps, and it's terrible. But if you turn on that high precision, you can see that is pretty high precision at that point. That works quite well. I like that. So that's cool. So I'm going to stop that. Leave that going. I'm going to stop my... In fact, I'll leave my... no, I'll stop this one for now. I'm going to switch back to my slides. And very briefly, I wanted to talk about Uno platform, because obviously you could do all of this remotely, and I like that. That's really cool. But you could write yourself a UI and run it actually on the Pi, and Uno platform allows you to do that. So this is like a UWP bridge that will run cross-platform, a little bit like Xamarin, but it will run nicely on a Raspberry Pi. So if you've not seen UWP, it's kind of like WPF really, but it's all XAML and C#, created by this guy Jerome Laban and his team over at Uno platform. Open source, cross-platform, and they're on version 3, which was released at UnoConf, and they're now using WinUI as well. And I think actually there's a conference or a session just about to be done by them Microsoft conference talking about this. In this preview version, they've got Skia and GTK. GTK is a graphics platform for Linux, and they're utilizing that and a bunch of Xamarin stuff to be able to deploy stuff onto a Raspberry Pi, which is dead cool. So let me quickly show you that working. Just 1 second. Okay, and let me do that. So this is when everything crashed earlier and I lost everything. So I have to load it back up again now. Just a sec. This one. Was there any questions while I'm loading this up?
Not yet, but I wanted to ask Goran that how many of these devices you have?
I would say a lot. Yeah, I also got some robot arms and such. I've seen on Learn TV for our question like how many devices people own. Some replied 0. So what you would Pete say is the easiest way to start? Like which device you would recommend as first one to start with?
It depends on your background. Just while I'm talking, I'm now deploying this application remotely from my PC, which slows my PC down, so I might get a bit jittery in a minute. It's going to deploy it remotely directly to the Raspberry Pi and run it directly on the Raspberry Pi. And I've got a blog post about how you go about doing that. But yeah, what we need to be doing is deciding on who you are and what your background is. If you've not done any programming before, then the microbit is an awesome piece of kit to start with. And if you use Microsoft MakeCode, then makecode.microbit.org, then you can start programming the microbit with a block-based language like Scratch, which is really powerful. And actually, the microbit itself is more powerful than a lot of people realize. It's got a built-in temperature sensor of sorts and a gyroscope and a magnetometer and a couple of buttons, and the newest version's got a speaker and a microphone. And people are doing AI with this sort of stuff as well. It's pretty impressive what it can do. The good thing about that is with MakeCode, you can switch once you've learnt enough out of blocks and into JavaScript and Python as well. So you can carry on programming in a higher up language, but still have the fun of the microbit. So I'd definitely start there. If cloud-based stuff is what you want to do, though, I mean, there's no Wi-Fi on a microbit, then there's a few different options. I mean, if you're a Microsoft tech person and you know a bit of Arduino, maybe, then you can get an MX chip device. And there's a whole heap of docs resources on the MS Learn site helping you take your MX chip device and connect that up to Azure IoT. And that's great, but that's all in C, and that's hard. So there's a middle ground where you could do stuff with the Arduino, and that is all C. But if you use something called Tinkercad, and I don't know if you've ever heard of Tinkercad, it's by Autodesk, and people make AutoCAD. And if you start out with the circuits element of Tinkercad, you can drag an Arduino onto that. It's really cool, and you can start programming it, but you can program it in a block-based language, which is fantastic, because if you want to start with an Arduino and C is where you're starting, that's hard for a lot of people to be able to do. So to be able to do that in blocks is cool. But what's really cool about both of these technologies is that you can download that code directly onto your device. So you're not stuck in a simulated world when you do these things. You can just download it. So you can download that block-based program that you've made directly onto your machine, and then you can use Arduino Studio to burn it onto your Arduino, and it will just work. And I've got some really cool demos that I do with that as well. And this is being slow, of course. Of course, it's being slow now. But I've got VNC sitting down here, and what it should do is start up the application directly on my Pi. And I think it is doing it, but it's just being slow because it knows that I'm demoing. So if this doesn't start any second, then I'll just cancel it and we'll move on to the next part of the demo because that's just taking its time. Let's give that a second or two more. It is actually doing something. I just don't know why it's not appearing on my Raspberry Pi robot. But either way, that would appear on there, and it would have the same sliders that you saw in the web app, and I'd be able to control the robot arm directly. And that's cool because you can have a screen on the Pi and you can just move it locally, which is quite nice. So let me just stop this code so it doesn't get too confused with itself, and I'm going to quit it as well just so I know that it's not going to do anything funny. It's probably going to end up still running in the background, and it's going to confuse the rest of my demos. In fact, I think I know what the... Oh, no, I did stop my code, didn't I? So, yeah, I don't know. It's complaining about something, isn't it? So, with all of that said, I'm going to close this piece of code here, and I'm going to run my robot arm back up again. Oh, in fact, no, let me stop that. Let me just go up here. What I've done to make this even cooler is that if you go to the address that Sherry and Goran are going to put in the chat there, I've deployed that same application. Myself and Liam Gulliver have deployed that same application to Azure that allows you to be able to move the robot arm. And what it means is that you can control that robot arm from anywhere in the world, which I think is pretty cool. So I've just changed it to point to that location. And if I start this up, and then...
So do you want me to share it on the screen?
Yeah, share the link by all means.
Yeah, I can do that.
And if I switch across to here... Oh, somebody's moving it. Somebody's already there. I think. So if I pull this back... So this is the app deployed into Azure, and you can... I know it's kind of going off there, but if you move this... Oh, look, somebody's doing it.
Sherry, you can also paste in chat. Will be clickable.
Yep,
Yeah.
absolutely. If I zoom out a little bit,
To make
then
it
it'll be
easier.
a little bit obvious there, look. So you can... what was really cool is that the first time I demoed this, me and Liam, then we had like 20 or 30 different people all controlling the robot arm at the same time. But then I demoed it on the IoT live show after that, and our good friend Shahid, who's a fellow MVP, had moved to New Zealand, and he dialed in and he was able to control the robot arm from New Zealand live. So, I mean, that's some long distance control, and it's in real time as well. So somebody's moving it. You can see because it says, please wait. So it's very rickety, and people tend to like forcing it to go into all sorts of funny angles. But the coolness doesn't stop there. So if I switch across here, I've actually made a VR app for the Oculus Quest 2. Now, we'll have to see if we can get this to work. So I'm going to put this on my head, which we've taken my headphones off for a sec. And you could be making funny faces at me now, and I'll never know. I'll see if I can hear you. Right, and I'll just grab the controllers. Right, let's see if I can cast this to my computer. Let's see if that works. So hopefully you'll see that. That's it. So can you see the robot arm moving now? Or can you see the robot arm on the screen, more to the point?
Yes, we do.
Yes, we can see it. Yeah.
So is that rotating the real arm and this as well?
It does.
Yeah.
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 There you go. So actually, probably what I need to do is I'm just gonna quit the app and start it because I think it might have lost its SignalR connection. I can see somebody else moving it, but can't see it moving. So I want to show the real demo, yeah. Otherwise, it's not doing the right thing for me. Is there any more questions in there, by the way, before we?
No, I think people are playing with the arm at the moment.
They are. They've been very well behaved. I don't hear it clattering and smashing into things. It's they've been very well behaved. Is that still casting, by the way? Can you still see what I'm doing?
Yes, we do.
Yes.
There we are. There, that's live now. So I'm moving that robot arm and the real robot arm from inside VR. And can you just about see the pincers? If I rotate this round to myself, you see the pincers in there. I can move those up and down. It's a bit backwards. Oh, somebody turned it around on me. Cheeky. You should be able to see the pincers moving.
Confusing.
Yeah, it's backwards because the way I wrote the code, so it closes when it's open, but it's still mega cool. And I tweeted that out, and David Fowler, one of the Damien Edwards, no, it was David Fowler, one of the creators of SignalR, actually retweeted it a couple of times. It was that cool. So,
Nice.
So there you go. So there is my, and all of my demos worked aside from the Uno one, and I'm a bit disappointed with that because that's a cool little demo too. But the coolest of them all, I think, is the VR demo, and I know nothing about VR. I had to teach myself all of this, and I sort of asking a few questions here and there, but I found a few good tutorials, and all of this code is on GitHub, by the way. So I'll provide the links to them, but it's. You'll be able to do that if I scroll across. So that's a little bit about Unity as well that I was going to talk about. Cross-platform, and it's all written in C# as well. So everything here is C#, which is just mega. And then that was that demo of the VR robots. It doesn't always go according to plan. My little cat decided that she likes the sound of these servos, and every time the servos come on, she would come along. And of course, if you don't fasten these things down very well, then they'd end up falling over. That's the jerkiness of that thing. But yeah, don't fasten it down very well, and you have an accident.
Nice.
So I've screwed it down now. And it's already fallen over. Look, it's fallen over here. Look, it can do if it's not fastened down. Ooh. There we go. You stay there, naughty robot. So so there's that. And then there's a bunch of links here. Don't worry too much about those because I've got this about Not So Tea tomorrow night, by the way, 6:30 GMT, Olivier Bloch. I've also made a bunch of Pluralsight courses about AZ220 and the Azure IoT stack, so it's worth checking them out. And then you can get in contact with me at a load of different places. But after this show, I'll upload the slides to that bit.ly at the bottom. So that's the only one you'll really need to look out for if you want the slides. You can get that. Email or Twitter. Twitter preferably because I can miss emails. So just send me a message on there and I'm happy to help with any of your IoT needs. And then that's it.
That's exciting. Thank you very much. And it seems like that people are so happy with the because the demo and everything. It was pretty exciting. So it's Nima among people. Let's say
I've broken it now.
Tony and Javier is. I guess he's worried about the robot arm.
Yeah. I think I actually broke the robot arm there when it fell over. Yeah, I think it is.
And we got one question like, how strong are those servos? Xavier has an idea with wooden interior door, including door and cats. Not sure what it should do, but maybe opening door for cats or
you can get far more powerful ones. Exactly, that's right. That might work. You can get far more powerful servos. These are like really low power servos. They can barely move the robot arm at times. Well, they can actually. It's okay for that. But I know Johnny Chips is a guy on Twitter that I get on with quite well. He built the version of this with better servos. There's a better 3D printed robot arm. The version of this robot arm, by the way, that I've got here, I've got off Thingiverse. But Cliff Aegis and his son Mac have actually created a far easier one, and that is also in the GitHub repo. And you just snap it all together with the servos and it just works. It's great. So don't try and build this. It took me about half a day to build this one and get it working, and I still messed up, as you see. So I think that's still working. I think it fixed itself somehow, but I don't know what it's doing. I think it's having a bit of a meltdown. It's probably that the Uno apps decided to start in the meantime or something silly. Who knows?
I guess Javier and myself, we have the same issue. So he has it with a cat, and I have it with my dog. I also would like to just lie back on my couch, and then when my dog is out, there is something totally open it and then close it. So if you want, maybe Javier, we can work on this project together.
Yeah, there's all sorts of stuff you can do. I saw a really cool project where a guy had hooked up a Raspberry Pi to Azure Cognitive Services, and he was able to then detect if his pet had got an animal in its mouth. So if it got a mouse in its mouth, then it wouldn't let it in the cat flap, which I think is quite cool. Because we know the mess that cats can make of things when they bring them in. It's just not nice.
Of course. Lars is asking, where are the Git links? We will have a blog post with all the links after the show, like in a few hours tonight. It will come out, so we will share that.
Yeah,
just here, look. But that's where it is. So that RPi robot is the link there. So I mean, by all means, you
private chat, we will post it.
Yep, there you go. You can stick that on there. Yeah. I mean, we could have been mega organised and got all these links ready to put on the screen, couldn't we? But I just wasn't that organised, so apologies for that.
Chat. But also in case you're not following ProDevs on Twitter, so after we are done with everything, so with the what do you call it, that the article, we are going to definitely post it on our Twitter
Yep.
handle as well.
Yep. Yeah, definitely.
Yep.
So there
Okay,
you go.
great. Thanks a lot for a great talk, and it was pleasure to have you here at the Maker Show. So
Thank you very much for
yeah,
having me. It's been awesome.
Yeah, really,
thank,
really thank you for joining us. So we promised all of you to have the. Let me just share my screen. Please, laptop, don't fail on me. Yes. Yes. So we have it.
There we
Yay.
go. There we go.
Yeah.
I feel it'd be wrong of me to claim that one.
But you will get the maker badge.
That's true. That's true.
Yes,
Yeah,
yeah,
because
I'm
you're
happy with
speaking
that.
at our show. Yes. So yeah, so you can all
Privileged.
go ahead and scan this QR code. You will get the learner badge. And if you want to know more about the project in general, you can all go to the aka.ms/azure.heroes. We have many different type of badges that you can either nominate yourself or a community friend. So if you, for example, you know a person like Pete that it cannot say no to all the community activities, you can definitely nominate that person for a community hero badge.
yeah.
So yes,
Nice.
so that goes for you and your community friends, and then we want to have your feedback because this is your show. We want to know that what you want to know, or who you want to get invited, or if you want to give a talk, we want to have you here. So Javier, if you ever made that project happen, you can actually let us know that we want to have all of this project highlighted here in that show. So that's not only Javier, that was an example. So any of you out there. so so you can scan this QR code and then give us feedback. And also, one of you that you gave a feedback, you can get swag box delivered by this badger to your address as well. So it's a surprise one, yes. So so please give us the feedback. And then the last thing is that together with Goran, we have actually a hackathon going on starting by next week, Monday. This hackathon is focused on climate issues. And what makes this hackathon unique is that all the challenges, it comes from a nonprofit organization that they have a lot of ideas how to solve that climate issue, but they might not have enough of technical capabilities. So you can all be there and do your part in order to solve this climate issue. Goran, do you have anything else to add here in this hackathon?
I think it will be awesome fun. At the moment, like 300 people, almost 300 people are registered, and
Wow.
yeah, will be really great week to do something for greater good.
Yeah, that's true.
Is Amy
This
Boyd
is
involved in that as well?
who?
Amy Boyd, is she involved in this as well?
Yes, Amy.
Yeah.
Actually, we have Amy. What she did is that we connected like a some cloud skill challenges with which is not finished yet. By the way, you still have time to join with that. And both Amy and also Hank,
Hank
they
Bowman,
created.
yeah.
Yes.
Yep.
So they created these cloud skills challenges to as a road to climate hackathon. So it's all about cognitive services, Azure machine learning, and then Power Platform. So you can use these skills and then join this hackathon. So I
Perfect.
really, really, really love to invite you all to join this because yes, it's going to be great if we can achieve something all together. So with that, our next episode is going to be on not March 21st, April 21st. Yeah, March 21st is actually Persian New Year that I'm going to celebrate, but, but
Ah, nice.
yeah, but April 21st. And we still don't have a confirmed speaker. So if you any of you want to
Oh,
Sherry frozen a bit.
yeah. There she got
Yeah,
stuck.
seems like it. Sherry, are you back there?
maybe Goran, you can continue. It seems like now it's my turn to not have internet.
Yeah. So, April 21st, right? We don't have confirmed speaker. If you want to give a talk, feel free to reach out, of course. And we'll give our best to make sure this is something really awesome, because April 21st is World Innovation Day, and we should be created to have a super awesome show on that day.
Yes. So
Sounds good.
that's all for now. And thank you again, Pete. It was a great pleasure hosting you here.
I'm just glad it all worked.
Yeah.
Yeah.
And we
I can go
really
drink
hope,
Guinness now.
yeah. And then we want to definitely to have you back at some point.
Woohoo. Yep, more than happy to
Yeah.
come back. Absolutely. Yeah. Just say.
Yes. Great. So then enjoy the celebration.
Hmm.
And
Yeah.
yes, so see you all later. Bye bye.
See ya.
See ya. Bye.